assignment 1 and assignment 2 are released. I haven't been asked for a single checkoff yet. So, but I have some submissions. Well, to be fair, the first assignment doesn't really require a checkoff, to be honest, so we can skip that one.
Free marks, right?
Huh?
You get free marks.
Free what?
Free marks.
3 months?
Yeah.
It's not free, you still had to do the work.
Yeah.
I don't know what to say about that. Free months. There's not such a thing as free months. Everything has a cost.
You don't have to pay the games going on.
Nothing is free in life.
You know what?
Okay, so the assignment 2 is released. In case you haven't noticed, let's just go to Rice Leads. I'm really looking to have our first exam before we go on reading break. That's my goal, but that will be 2 weeks from now, so that might be a bit too tight. But we'll see. I'm not gonna be unreasonable. Like, I mean, if we're not prepared, we're not prepared. But we are into libraries already, so the part that we're kind of lacking is on the working on the assignments. I don't see a lot of stuff there. Yeah. The first exam usually includes the first 4 assignments. Okay, so assignment 2 is here. So assignment 2, if we click on it, here it is. We click on the link, right? Same as the other one, and the description is here. Now you have to fill out these tables with information that you get. And since I'm asking you to put everything in the markdown, remember that we did that? So you may be wondering how you're going to do a table. So I gave you a template in Markdown that you can.
For anyone that's having trouble with Markdown, if you want to format it easier, download something called Obsidian.
Okay. Yeah, that's a good information. See? Yeah, so I gave you here the table so you can just fill whatever in there. And it doesn't have to be aligned. It will render, see if that is not aligned, when you render it, it will be like that anyways, right? So no problem. Okay? So just have to put it inside there. So the tables are ready for you to use, and you just fill out the information. Okay? Any questions? So this assignment, bitwise operators. And yeah, and the third assignment coming, which I'm going to release this weekend, is now just going to include actual work with the board. We're going to start, because we already know how to toggle things. We know how to see a signal on the scope. We know how to generate some time delay based on cycle, right? Okay, so before I get into the content for today, but let's just do a quick. This is our section 1.
No, I just pushed it to keep it.
So I guess, let me see, what's the issue here? So our 10 was GPIO review, our system. I'm not sure if this is yet. We did the GPIO review, right? We went over the actual process of, we went over that.
And you presented a challenge to turn the while loop that was in there into a function.
Yeah, but we went over the actual lesson for the motor and the ODR and the IDR. We did all that. So that was lesson. So now it's lesson 11. Now we're going to do intro to libraries. Okay. All right. So for these, we're going to open our repository. And this is in class demos. And where is my home? Oh, I have to practice and stuff. Is this my actual?
Is there a new demo?
No, this is address, bitwise. Yeah, this is what it is. Board demo is the last one that we did, right?
Yes.
So we play with these, we added a delay there, and you guys came up with these numbers and all that. Okay. So when we have these include clauses like this one, we are actually including libraries. And remember, the include clause is a preprocessor directive. That's why it starts with a hashtag. So that means that this gets done before compiling the program. And what does that mean? Before compiling the program, these two libraries get added to the package. Okay? That's what we say include. So we're telling the compiler, hey compiler, I'm gonna give you my code plus whatever is contained in these two libraries, and we're gonna put it together and you're gonna compile my code. So if I use any functions that are included or type definitions that are included in these libraries, the compiler will know about them because it's included. Okay? For example, when I define this uint32t, this one is defined in the stdint library. And this is a custom type definition just to be explicit about the size of the integer, because sometimes we may be confused. The ones that, for example, had micro 1 on the older micro, the unsigned int in that micro was 16 bits. Now in this micro, the unsigned int is 32 bits. So we may get confused, it depends on architecture, but when we use this library, we're being explicit that this is 32 bits, or if we use uint16_t, we're being explicit. But these things are defined in the stdint library, which is part of the standard library of C, the whole package, okay? Now, when you do this from VS Code, you may get wrong information. If I press here and I hold control and I click on this, where does it take me? Can you see the location of this file? What does it say?
Many file layers deep is where
Yeah,
it's
but where is it? It's like where? Microsoft Visual Studio 2022. What does that have to do with our micro? Nothing. So Microsoft has its own implementation of stdint. And this is not the one that we're using. See, so you cannot fully trust VS Code. It's great for IntelliSense, but we actually need to open our Seger. Okay, so we're going to open this project in Seger. And now we're going to try to navigate this library from here. So we can do the same thing. Hold control. No, I think we cannot do that. Yeah, we can. Hold control and click on the library. And unfortunately, it doesn't tell me what this library is, but I think there's a way if I right click on it and I say select in File Explorer, it's going to give me the actual physical location of this library. And that is where? In Seger Embedded Studio. In this folder here that has all these include, it has all these libraries. The string library, the stdlib, the standard input-output that we use, all these ones are defined here. And many of these libraries are part of the C standard library package. Now the C standard library is available online. In fact, we have links to it, I think, in Reisner somewhere, where you can check the standard library and its documentation. However, the part where we need to be clear is that since we're working with a unique platform, it's a unique hardware, okay? It's not a desktop computer. Every unique hardware needs to have its own implementation of the standard library. So it's gonna be 99.9% same as the actual standard library that's available worldwide, but not necessarily exactly the same, okay? In fact, if you use printf, which is part of the standard input-output, STDIO, right? It happens that in this micro, it goes to a virtual console. But that is because we're just lucky enough that Seger implemented that. In other micros, you don't have access to printf because printf is meant to go on the actual console of the computer that has a screen and a video card. And this is not the case of this micro, okay? So we always need to ask ourselves, because when we look for things online and we see this standard library, are these things really implemented for our micro, right? So we need to ask that question before you just go and use it, right? In most cases, will be, but we have to be very careful. And what is the way of checking that? Well, going in here. because the manufacturer, the guys that worked on this IDE, created this standard library package for us to use. And if you use a different IDE, they may have a different one, but it all goes based on the architecture of this mic. Okay? Any questions about that? Okay. So when we include libraries that are with this sort of like brackets versus these double quotes, what is the difference? Normally when you include with double quotes, it always works, but it's more of a convention. When you're using these brackets, you are including this library from the system libraries that are available. And when I say system, I refer to the IDE. So the folder that I showed you, all the libraries that you include from Sager.program files, whatever folder that I showed you, should be included with these brackets. Whereas these ones are more located within the project itself. In fact, this one, in case you hadn't noticed, it's located somewhere in here. Every time we create a project, Sager creates this folder, and then inside device, and it has include. See, and this library, it's somewhere in here. Yeah, it's right here, see? And it also adds all these other ones, although we don't need them, right? But every time you start and create a new project in Sager, it adds this folder, and inside device, it puts all these libraries. So these are actually inside the project folder. See what I'm saying? So that's why they are included with double quotes. Now the question is, all the libraries that you are going to create, are they going to be included with brackets or double quotes?
Double quotes.
Double quotes. Because although they're not going to be inside the project, they're going to be here, okay? But it's part of the custom environment that you are developing. It's not part of the one that is given to you by the manufacturer. Okay? Is that clear?
Yes.
Okay. So how do we then create a library? Well, to be honest, the easiest way of creating a library is going to be starting here from VS Code. Because you can do it from Sager, but every time you want to do it in Sager, excuse me, you have to have a project open. Whereas in VS Code, you don't have to. You just go to these folders. And this is what the idea is. The idea is that you place all your libraries in here, and they're a unique set inside a folder that are available to be used within all the projects. Okay? So every project that you declare inside your ICAs, inside your labs, or eventually inside your practice folder, all of them will use these libraries. But in the setting of the project, we gotta tell it where those libraries are. Unfortunately, we have to set that up in the IDE. Okay? Now, questions after this one? No?
Wait, so you created all in VS Code, not in Sager?
Well, you could do it in Sager as well, but I think it's easier to do it from VS Code, because then you see the entire. See, what I do always with VS Code, I do this. I open my home repository from desktop, and then I go repository, opening Visual Studio Code, provided that you have Visual Studio Code installed. You may want to open in Notepad++, or whatever other editor you like, or Sublime, I don't know. Sublime is not that popular anymore. But yeah, it doesn't matter. Any code editor will do it. VS Code is very popular, and it has good IntelliSense. So the idea is that, oh, I don't have any libraries.
Oh, no.
Yeah.
Create
So-
one right now?
You can demonstrate that, and then.
I'm gonna do that,
Yeah,
but I'm not gonna give you the entire library. Right? No, by no means, yeah, I'll do that. I'll give you some hints, but yeah. So let's do. Do we have actually any libraries yet available? Because I'm supposed to give you the headers. Yeah, no, I have to expose the GPIO. So in GPIO, I'm going to expose this topic 3, and we have somewhere in here Oh, because it's broken. No, here. We have a GPIO-H. So normally we're going to give you the header file, okay? And you will just have to do the implementation. But before we get to that, let's go to this project. So this project was using this, but then, does anybody remember the number that you came up with for the delay?
1780.
Yeah, okay. So, but before that, in some spot here, we're going to have some something that we call function prototypes, okay? And you realize already with the practice that any function that you declare has to be added as a prototype here, right? So, but you know what? I'm going to create another project because this one is already modified too much. So let me just, I'm going to call this one number 10. Function demo 1, okay? It has to be lowercase. Name this one. Oh, come on, rename. Rename. Okay, so I'm going to have in a section here my function prototypes. And the way I named this function, what was it? Delay 1 millisecond? It doesn't matter, whatever name I can put. The function prototype should contain the signature of the function, okay? And the signature basically refers to what? The name of the function, what does it return, and what does it take as a parameter. It has to be explicit. If it doesn't take anything, please put void, not empty brackets. Okay? This is a function prototype. Now, or function declaration. We could also say function declaration, which is different than the function definition. So that one is going to come here at the end. We're going to have a spot here that is called functions. And then in here, we're going to add the same thing, but we're going to say this is a function definition now because we explain what it does. And it doesn't have this semicolon, but it has curly brackets, right? And implementation is going to be here. So then we did this, right? We did something like, what was the number you guys came up with?
38.
38 or something like that. Whatever, it doesn't matter.
1780, 1781,
Yeah, it depends on how you
1779.
implement it, right? Yeah,
Whatever
let's
value
do
you like.
1780. By no means take this for granted. You gotta implement your own. And then in here we did this. We call this function with this, right? And that's beautiful, and it works, and blah blah blah.
I thought you said you wanted us to place that into a for loop.
Well, because that's a different function. That's a function that delayed now for X milliseconds, right?
Oh, my apologies.
Yeah, yeah. So this is just the first example. Now, as you can see, the approach here is to have all the function prototypes on the top, the definitions on the bottom. But this happens, for what we know like local functions. What are local functions? Local functions are functions that are meant to be used within the same file. In this case, main. Okay?
Wait, quick question. Does that always have to be at the top?
Yes.
Okay.
Oh, yeah. That's a good question because the compiler
Yeah.
starts from the first line. So if this is not here, the compiler starts. Oh, okay, RCC. It's going to say RCC. Well, I know about RCC because RCC is defined here, right? And this was included before preprocessing, right? Then it keeps going and it says RCC. Yeah, I know about GPIO-A because all that is in the library. Here, oh, I don't know about this guy. I know nothing about it, right? And how can he know? Well, if this thing is declared here, then the compiler went here already and said, oh, this is a function prototype, so that means that it's declared down below. So it knows that this is declared. Okay? If this is not here, the only workaround would be to actually have this part before me, put in here.
Gotcha.
Then why don't we do that instead of doing this thing? Well, because it becomes a mess, because when a function is calling another function and that one calls another function, then which one goes first? Right? Whereas if you have many functions, they can all go here as prototypes and be declared at the end, and it doesn't matter which order you follow. Okay? But there's a problem with this. And that's the reason for the libraries to exist. As your program and system starts growing, you will have many, many of this. You could reach easily hundreds. So you're not going to have 100 prototypes and 100 functions defined somewhere else. So you need to start packaging those functions into things, put them there together when they belong to the same thing, when they're similar, right? For example, these stdint, we went to the definition before. Oh, did it work? This one has a bunch of custom type definitions, and all of them refer to the different ways of defining an integer or a number, right? So then they all belong to the same file. So that's why they were all put into the same file. So let's say that I'm creating a driver for a display or whatever thing that I want to create. So it will make sense that I put all the functions related to that display into the same file, right? And that's what the purpose of the libraries are. So now, we're no longer going to have these things defined here, we're gonna place them in libraries. And these function prototypes are going to go into the .h files, and the function implementations are going to go into the .c files. Okay? How is that gonna work out? Any questions up to this point? Okay. So let's say I want to create my first library. I'm going to go to Brightspace. I'm going to grab this GPIO.h. I'm going to download it. And I'm going to place it where? Well, in my repository, inside my lib folder, inside my ink subfolder.
So not in your OneDrive. Gotcha.
Not at all in the OneDrive. That would be terrible. Yeah. For me, it's already in here. Okay, so I'm not gonna overwrite it. So you download it and you put it in your ink because it refers to the includes. Those are the libraries that you're going to include, the .h. Those are gonna be given to you at the beginning. You can modify them, you can add more things, you can do whatever you want, but we're giving you the bare minimum that needs to be implemented. So let's assume that you downloaded that already. So you went here, but why is it not here at all?
Is it the right folder? Or
Yeah,
do you-
maybe it's not. Yeah, so see, I don't have any libraries here, which is good, which is really good, because then it means I can actually download this. Yeah, this is 2250, that's why. And see, this guy is put in here. Okay, so I'm gonna place it in here, okay, H file, in the ink. Now, what I'm gonna do here from VS Code, I'm gonna open that file. It's right here, see? And I'm gonna drag it on the right. And this is the file. Okay? And these are all, what are these? Function prototypes. Okay? Description of the signature of the functions. What does it return? What does it take for parameters? I even describe the parameters here. Now, I'm doing something a little bit bad here. That is, it's just me. Some other instructor won't do it. So if it bothers you too much, we can try to fix it. It's just that I don't know why. I feel like this is the right way to do it. The function prototype, again, states the signature of the function. What does it return? What does it take as a parameter? Does anybody see anything missing in this function?
Variables.
Variable names. See, some students get confused and they start using this. No, this is a type. No, this is a custom type that is defined somewhere here. Anyways, but this is using the stdint. These are types. Why don't I put the variable names? You can put them if you want. You can call this one port, you can call this one pin. It's just that I feel like the prototype needs to have just a bare minimum because it's just stating the signature of the function. It's not the implementation. Now, let's say I want to do the first implementation of the first function. Well, init output. Although it's not the first one, but it's the first one I picked. Where do I put it? Well, I need a, obviously, what do I need? Does anybody know aside from him? He already took the course. What do I need to implement this?
Don't you need to open up something like a new file?
Yeah, I need to create a new file. When am I going to create a new file? Anybody guess?
Go file, no, maybe.
In SRC,
Yeah.
because this is where the source files are.
That was my next guess.
So, new file, right click and new file. What am I going to call this one? GPIO. Dot what?
C.
Dot C, because it's the implementation. Okay?
Yeah.
Right.
Right.
This on the left side is going to implement what I gave you and you put on the right side. Okay? Now, what is the first thing I should do on this file? What is the first thing I should add? Include. Oops. Oh, what did I do? Include which? GPIO.h. You see, the AI is already telling me that. Because this one is implementing this one. Do I need to include this one?
No,
Perhaps.
Why not?
because it's already in the GPIO.
Yeah, it's already in here. So when I include GPIO.h, I include everything that GPIO.h includes. GPIO.h already includes this. Why? Because it's using this. So if I don't have that, it's not going to recognize this type. Remember that this is a pointer to the data struct that has the port with all the registers. So if I don't have this one, that one is defined here. So if I comment out this one, just for the sake of demonstration, then the code doesn't know anything about this. See? All right. So when this library is including the header file, the derivative file, then this one already knows if it includes GPIO. Okay. So the first thing I gotta do is I'm going to implement this one. And I'm going to remove the brackets. And the AI is already telling me what to do. Now, you see this thing here, but this is an issue. I'll tell you what this issue is. It won't happen with the other libraries. This issue happens because Microsoft also has a GPIO library. And this is kind of expecting to have the Microsoft one, but this is just VS Code. Remember, VS Code is just the editor. It's not ultimately. The important thing is that this works on the actual Sega. Now, whatever the AI gave me here, well, what is missing here? Well, now I need the variable names, right? Because this is implementation, it needs a variable name. So I'm going to call this one pport. Why? Because it's a pointer to the port. Okay? And this one I'm going to call it pin. Oh, it's already telling me that. There we go.
So you don't even have to type it.
Well, you know, this thing is good, but it makes mistakes. So you gotta make sure that you know what you're doing. Let's check this. Is this correct? Does this ring a bell?
Oh, yeah.
From what we've been doing? See where I'm going with this? You're passing the port. Now the port pointing to model. Now this function is gonna work for any port. GPIO-A, GPIO-B, GPIO-C, doesn't matter, you just call this function. And then the pin is gonna be a number from 0 to 15, gets multiplied by 2, and does a bit shifting for clearing the motor, and this one is for setting the motor. I could add that's in hex, but if you wanted in binary, yeah, probably will make more sense in binary, right? We could do 0B, 1, 1, and then we can do 0B, 0, 1, right? Something like that. All right. Any questions? How do we do the input?
Yeah.
Oh no, no, it went away. Okay.
GPIO underscore.
But see, sometimes it becomes annoying, so I prefer to disable it sometimes. Okay, so let's do the same thing here, P port,
Just clear.
and then pin. Okay. Is that correct?
Yes.
Yeah, because in here I only need to clear because what I want is just to have 0 zeros. So, and suddenly I'm giving you the first two functions, right?
Can I take a picture of that?
No need.
But if you have compilers, it will also do it for you. Now, it's not that I'm encouraging you to use compiler. You could use it, but you have to always verify that it's doing the right thing. And you know how to do this, because it makes mistakes,
It does.
okay? So I'm telling you, I've seen this multiple times already. Now, if it bothers you, you can disable it from here. Any questions so far?
Oh, yeah, just why is it showing errors?
Oh, this is because of, I said, it's because this Microsoft thing also has a GPIO.h, so it's a bit confused and it thinks I'm using that one, and it's creating a mess. But this is just VS Code. When we use it in Seger, it will work.
So how would you open this on Seger?
Yeah, that's where I'm getting.
Okay.
Okay, so I got that one. What else were we doing in this demo? We were doing a delay and then we were doing a toggle, right? So I guess I have to implement the toggle, right? That's starting to become annoying. Okay. Is that correct?
Port, ODR, XOR,
Yeah,
appears
that is
so.
correct. Okay. Now, are you going to be able to see this code that I'm saving here?
If you push it to Git, we will.
I will push it. I will push it. Push. See, everything happens for a reason. Keep always that in mind. I've pushed to my repository. Are you able to see this code? No, because this is my repository. What are you able to see? This folder, the in-class demos. So whatever I put in the class demos, you're able to see. Now here's the funny thing. Why do we do this weird structure with the submodule? Now you understand why we're doing it like this. Because when I give you my demos, and I use the libraries, which libraries am I going to use?
Your own.
My libraries. You're going to run my demos with your libraries. Then if my demo doesn't work, the student's gonna approach me and say, Carlos, your demo doesn't work. What do you think I'm gonna say?
Check your libraries.
Yeah. I'm gonna say, no, my demo does work. It's your library that doesn't. Okay? So this is a way of testing your library. So you gotta make sure you do your implementation. Okay? So what we're gonna do now, hopefully I don't run out of time. I'm gonna copy this demo. I'm gonna create another demo 11, and we're gonna call this one library demo 1. And we're gonna revisit this topic, okay? Don't worry, because this is way too much to process in one class. Okay, so we're going to do it here. And we're gonna open with Seger, okay? And we're gonna rename it to the proper, I don't know if I renamed the other one, I might have to fix that one as well. Okay. So what am I going to do now? Well, this port enable and all that, that needs to remain because that's not in my GPIO library, so this needs to remain here. Now configure PA5 as an output. Gone. GPIO init output. Ah, but it doesn't work. Why?
Because it didn't have your library.
because I need to include
Oh,
GPIO. Oh. Oh, now I have a problem. Doesn't know where my GPIO is. Right? See, this is where the problems start. But these problems are solved only once. If you know how to do it, then you're fine.
Point it to the correct
You need to
location.
tell the IDE where your libraries are, because the IDE knows where Sager libraries are by default, but it doesn't know where yours are. So then you need to right click on the project and say options and go to preprocessor and then go to user include directories. User, your include directories. And you're gonna do this. Let's take a look at the structure. That's why the structure is important. This is the project folder, right? How do I find the libraries from here? I need to go one level up, 2 levels up, then go into this folder, and then go into Inc, right? Again, whatever this one is. 1 level up, 2 levels up, then find from the lib, right? So how do I do that here? Dot dot, backslash, it could be actually forward slash as well. Dot dot, backslash, dot dot, backslash. Level up, level up. That's how you do the navigation of the folders, right? Then find the lib folder, then find the Inc folder. Done. What is going to happen if you decide to move the folders around?
It breaks.
Yeah. What is it going to happen if you use the Evil One drive? It's also going to break because it's just going to keep doing things. Oh, didn't like it. Oh.
like no way to like.
Oh,
browse
did I save it? No, well you could no. That is not recommended.
Okay.
To add absolute paths, no, because the idea is that no,
Oh.
that's,
Didn't, well, you didn't add the library near the main.
huh?
You didn't add the library near the main.
Yeah, that's coming after, but at this point it should recognize it. Maybe I didn't save this.
That's
Go to the project
that
and
use that file.
Interesting.
Yeah.
Oh, maybe I didn't save it? No, but this is just the other thing. It's in here.
the
Copy the
project
S.
directory.
Project.
Tell it to go into project directory and go
The
back.
project word.
No, I have tried this way.
Oh, I think I'm on the wrong. Oh, I have 2 things open. Yeah, I'm creating a bit of a mess here. So sorry.
Good old
That
Sager.
might be the problem. I have so many things open.
There it is.
See, he's reenacting what I do at home.
Yeah.
I'm confused.
So let me just open this project correctly. Yeah. Let's go do this one again. I'm gonna clean the project. I'm gonna build the project. And it doesn't like it. Because of this. Yeah, I need to update that, guys.
To a 32?
Yeah, because this is no, it's B1 because it's using the old micro. Yeah. So I will update that one on Brightspace because it has the old micro. Okay, now it does recognize it. See? Now I can do. What was I going to do? GPIO underscore init output. What do I pass in here?
GPIOA.
GPIOA and then comma 5. See, and now this is looking almost like an Arduino library, right? But the difference is that you coded it, right? So you can update it, you can change it. And in here, what am I going to do? GPIO underscore what? Toggle. GPIOA, comma 5. Oops. And now everything is beautiful and more readable. I can get rid of this.
Oh, that looks so clean.
Yeah? Okay. I'm going to rebuild. And I still have a problem. Symbol GPIO output reference is undefined. Well, here's the problem. I have included the library, however, I don't have the implementation added. So these are the two steps that I need to do when I'm using libraries. I have to include it here, so it does get recognized, but in order for the compiler to actually see the implementation, I need to add the source file to this source files folder. How do I do that? I go to my libraries, I grab my GPIO.c,
Copy path.
and just drag and drop in here. That is the easiest way to do it. You can also do right click and say add existing file, but drag and drop always works fine. So now all the C files of the libraries that you are using need to be added here, otherwise it won't work. And they need to be also included here. Okay? Now I right click and I rebuild. Now everything works. And now my GPIO toggle should be working. Now I think I ran out of time, so I'm not going to test it, but you guys are welcome to test this, and I'm going to push it.
That should work.
So you can see this in the lid.
So vol.
Yeah, but you have to implement your, no, you can't see my list. You have to implement your own list. But remember, you have to fix that in the
Yeah,
library.
because you essentially
If I don't fix it,
you're
you
coding
change to
it once,
0v1.
never coding it again.
Because 0v1